Welcome everybody to TechnoScope. This is the channel for all things tech and gaming hardware. Today I'm going to do a follow-up video on the Monoprice Select Mini 3D printer. In my opinion, if you watch my review, I determined for a beginner like myself, this is probably the best printer out there on the market. It's cheap. It's about half the price of most what are considered cheap printers. You don't have to assemble it. It comes fully assembled, pretty much ready to roll right out the package. There was a little bit of tweaking, but very little. There was no real assembly involved. This video is about what I had to do to get everything up and running and what you see here. So we'll get into that right after this.
Welcome to the channel. This is TechnoScope.
So the first thing I want to discuss is things that I've learned about this printer since I've had it. As you can see from the side of the printer, I'm using the painter's tape that I bought to add a little protection here, and on the spool. I don't know if you call that a spindle or whatever, but the thing that the spool of PLA or whatever material you're printing goes on. That's because I noticed that as it prints, the PLA usually comes from back here when I load it, comes up this way and goes into the feeder, and it rubs against this. Meanwhile, the side of the spool rubs against this section here, and of course the spool itself sits on that. So I just put those pieces of tape on there just to protect the printer itself, keep it from wearing out, and it doesn't look half bad. So why not? One thing that I will say is, I kind of alluded to this in the last video. This is actually the second printer that I've had. The first printer I sent back because of a problem that this one has as well. I guess it's not a significant problem, but it's something that I thought I should bring up. When the hotbed or print plate, I'm not really sure what the official name for this is, but the hotbed or whatever you want to call this, when it's in the home position, what they call the home axis, after the first initial run of prints that you do, it stops reading the temperature from this plate when it's in the home position. And it took me a while to figure out that it was only doing it in the home position. When the plate actually moves, it starts reading the temperature again. So I'm guessing that there's a connection somewhere under it. I haven't actually looked, but I think there's a connection or something that just doesn't make the right connection when it's in the home position. So how does that affect you? Well, the plate itself doesn't warm up when it's not being read. And you'll know it's not being read because on the display up there, it'll read 999 instead of the actual temperature, which should, when it's cold, should be somewhere around 20-something, 30-something degrees. But instead, it'll read 999, which means that it's not reading the temperature, which means, for all intents and purposes, it's already over temperature, so the printer will not heat the hotbed. And that's where I was coming into problems with the other one. That's actually how I ended up with the painter's tape. Painter's tape is good depending on which PLA you use. I know that's kind of weird, but I've come to learn that some of them are more adhesive than others. Some of them are very, very, very sticky, like what I use to print Groot. You lay it down, it lays down very smooth, and it adheres like you were, attaching it with glue or something. Other PLA like this Frankenstein right here, I had a very hard time getting it to stick, and it will not do it without a hotbed. Period. One of the other things I learned is that the painter's tape doesn't work with heat. So when you are using painter's tape, you don't use the hotbed. You turn the heat function off. You can either do that in Cura when you're setting it up, or you can use this control which allows you to change the temperatures after you've even started printing. So you just want to turn the hotbed off whenever you're using 3D. I keep calling it 3D painter's tape. But in the end, I determined that the actual problem that I was having, there was actually two problems I was having. If we switch to the other camera right here, I don't know. This is a GoPro, so I'm not sure how well it actually focuses. I'm not sure if you can really tell or not, but there are a lot of gaps and holes in the texture of this thing, and the reason for that is I found out that I was using the wrong printer profile. I set up Cura wrong on my desktop when I was configuring everything. I did it. If you remember on the first video, I set it up on my laptop first, and my laptop created all the good prints that you see, the ones with holes in them. These three up here, and very, very thin, loosely made, not quite well made PLA came out, rough because I wasn't using the right profile. Now, I will say one thing, because these are Halloween decorations, that was actually a good thing for these. I reprinted the skull, and again, I'm not sure if you can tell in these in this camera, especially with the GoPro trying to blow everything out. Let's see if I can get some shade for it. I'm not sure where the light's even coming from for it. Over here, I guess. Okay, let's see if you can. I'm not sure if you can tell. This is a low resolution monitor that I'm working with here, but it has a very rough texture on it on this one, whereas this one that printed how it should has a very smooth texture. Now, I will say that this one right here was printed at 100% infill, while this one was only printed at 25%, or it might have been 50%. I'm not sure, but it has it not only is it much thinner and much more flexible, but it has a very rough texture, and that's actually desired here because you're imitating a skull, and bones have a lot of holes. They're very porous, so it actually benefited this print right here. This is kind of weird, but you're not going to want that on most prints. The Halloween decorations are going to be the exception to the rule. I will get to these other prints in a little while, but I just wanted to let you know that I thought the problem was the PLA, but it turned out it was just the settings I was using in Cura. Make sure you go through that guide on that link that I provided, and I'll provide it again in this video description. Make sure you use that link, set up the software the proper way, because otherwise you get these prints that don't print quite well. The other problem that I ran across was the PLA not quite sticking to the hotbed, and I played with temperatures and settings a lot. In fact, I'm gonna grab the fails that I made. Okay, so in addition to a lot of other fails that I made, I actually had these as well. This was 100% PLA or 100% infill. The PLA really was not sticking to the hotbed at all, and it would get to a certain point. I mean, it laid down a lot of PLA, but before it got to this point, but eventually it got to the point where it was bowing at the bottom, and as you can see here in this video, it's not sitting flat anymore. So what happened was, as the print head goes across it, it would eventually break it loose of the hotbed, and at that point you have a failed print, because there was a lot more to go, because I was printing the full Frankenstein head, and we were still on the base. So at that point, it's just a fail. unfortunate, but what I learned from that was, number one, don't use the 3D painter's tape. Keep calling it 3D. I'm not sure why. Don't use the painter's tape for all PLA. Some of it sticks better than others. The other thing that I ran into was this hotbed was not perfectly level. That printer head has to be very, very, very close to the hotbed. In fact, I mean, you can see that it's spring loaded. If you actually look at it very closely, you nearly want that print head in contact with the hotbed. That's pretty much what you want. You don't want to dig it into it, but you want it pretty much in contact with it almost. And eventually I learned, I kept going through there and adjusting each one about a quarter to a half turn each test. And finally got to the point where I got them all level, and you can tell which one is not adjusted right because as it goes around, it makes it, as it does the platform at the bottom, it does circles, and if one side of the hotbed is not high enough, that side will not stick. So you'll know that that's the one that you need to bring up more. And eventually I got all four sides set straight, and I printed this guy right here. So came out pretty well. I printed this one before the Frankenstein. I'm gonna switch to the other camera here again. You can see that the back of it is kind of up. It's not flat like it should be. Like this whole platform piece right here should be a flat thing, but you can see it's up right here. That's because on this one particular part, it wasn't adhering like it should, and it was starting to fold up, and the printer was hitting that, and it just kind of integrated into that portion. Luckily, this one passed, but the Frankenstein would not get past that point. This PLA right here is supposed to glow in the dark, but really doesn't. This one right here has some cool properties I'm talking about in a second. Okay, so the other thing that I want to discuss is these pieces here are made out of specialty PLA. These two right here, the 100% infill skull, as well as the jaw piece that I never printed for this one. These are the same skulls, just one is printed differently and wrong, and one's printed at 100% with the right settings, and as well as the jaw. They're supposed to glow in the dark. This PLA, I will not suggest it at all. I won't even link to it because it's just junk. It's junk as far as glowing in the dark. It's not junk as far as actually printing. If you want white PLA, it's great for white. The only way to get this to glow in the dark is to have it outside in bright sunlight and then immediately take it into a dark room, and you will see it, have a faint glow of blue. That's pretty much the only way to get it to glow. I mean, even with the bright lights I have in here in my studio, I just can't get it to glow. This one right here is actually glow in the dark PLA as well. This is pretty nice. Let's see if I don't know if I can get the camera to pick up on this or not. I think you can sort of see it. It glows in the dark as green. And this PLA right here is much, much better as far as glowing in the dark. What is this? This is the brain for Frankenstein. So it needs to go in here. So what's so special about Frankenstein? You might have saw it when I was handling the fails over here. Frankenstein, let me show you right here, is made out of a PLA that when you warm it up, it changes colors. So the temperature from my hand is actually warm enough to actually make it change. You see that? So now instead of being brown, it's green. Pretty cool. The actual model that I made this from, he had it in a green he had printed it in green PLA, and I thought it was just perfect for this. You handle it at all, and it just changes colors on you. This PLA was originally meant to print Groot with, Baby Groot, but I didn't have it in time, so that's what happened with that. So I'm gonna go ahead and start taking some of this off. I want you to see all of this stuff that's around it is what is the support material that the software adds, so that when you print things that stick off from it, they're not drooping or not adhering to anything. They're just, because they're kind of free floating. So they print this support material so that it has something to actually stick to. Because you don't print from the top down that's already there, you print from the bottom up. So let's go ahead, and you can see it changing colors. Now when you print this on the printer, you'll wonder if it actually changed color, because the entire thing, because of the hotbed and because of the extruder is warm, the entire thing comes out green, and the entire thing was green for about a day before it actually cooled off to the point where it was brown. But I think this is pretty cool. Look at this. The whole top of the head is almost green now, just from me handling it. And then again, this is just stuff that you just break off. Some of it you may have to cut off. I strongly suggest, if you don't already have some, go out and get a small pair of diagonal cutters, because this is the most used tool I've used while 3D printing. So you definitely want to get a pair of those if you don't have it. One of the other things, I'll go ahead and say that while I'm doing this. Let's go back to the main camera. One of the other things that I learned, especially with this PLA that has a hard time sticking, you don't need painter's tape with the printer, because the hotbed actually has a unique property when it has this type of material on it. Print with the hotbed on. I usually print it 60 degrees. When the printer is finished printing, and if you notice from my review video, I was trying, with all my might to get the PLA off. Don't do that. It turns out if you just let the PLA cool off, once it's finished printing, all the heat switches off on the printer. Just let it cool off, and eventually it will actually shrink on its own enough to break itself loose. Might still need a little bit of a nudge, but nowhere near as much as it took from those first prints. So let's go back to this camera, and I'll show you. I'll finish removing this material. Man, this is like this right here. This is goodness. That is strong stuff. I did not print this at 100%. I think this is still 20%. I started to print it at 100%, but the fails made me rethink that. But this is goodness. This is strong stuff. So I'm gonna have to cut this off of his ear. And again, I mean, 3D printing is partially about cutting stuff away, because support material is used so often. What I haven't done, which I should do, and which I recommend you do, is go get some very, not super fine, but some fine sandpaper, so that once you break this stuff off, you can sand down the pieces that have support material remaining. That way you can make it look good like you want it to. Man, this is very strong stuff. Wow. I almost need goggles to do this, breaking off this super strong stuff. Look at that, you got some serious boogers going on right there. You got serious boogers when you need cutters to clean your nose. Look at that. Got a face only a mother could love. And you can see this thing is almost turned completely green just from me handling it. It's pretty cool PLA. I like this. It's one of the unexpected joys of 3D printing that I didn't expect was that there are so many cool different kinds of PLA out there, or print material period. And I really didn't understand. I didn't know that I would be able to print, things that change colors and things that glow in the dark. I had no clue. It's pretty cool that they have material that does stuff like that. And I'm always on the lookout for anything that's new. So if you have any suggestions for any kind of PLA that you think I should try out that does something pretty cool, definitely let me know that. I want to try a lot of other stuff. There's I've determined that my favorite PLA company is 3D Solutech. The chocolate brown that I printed Groot out of was that company. Not that I can't use other brands. I just like their PLA for what it is. It's very cheap stuff and it prints very well. I mean, it's in some cases half the price of some of the others. So you can't really go wrong with it. They also make flexible 3D print material. And I think that's what I want to try next. So that ought to make some very interesting stuff. Wow, okay, I've got most of it off. If you can see down here, this whole cross hatch thing is supposed to come off. That's just support material. Yeah, I'm gonna have to play with that. But you get the general idea. And I've cleaned it up, so that is Frankenstein. And we need to do Frankenstein's brain next. So wow, this is strong stuff. Ow. Wow, it really poked me there. It made me think that, if you made a knife out of this stuff, it'd probably do some damage if you wanted it to. This PLA, it's brittle. It gets hard and it's brittle. But if you print this stuff at 100%, I can see now how NASA was able to use this stuff in space, because this is ridiculously strong. Yeah. There are red dots on here. I think I might have actually got blood at some point. Which is perfect for Frankenstein, I guess. Maybe we should wear gloves or something. The perfect tool, I think, for doing this would be a pair of needle nose pliers. I have my cutters here, but I don't have my pliers inside the house. And I don't feel like going to stores to get them. Look at all the material that's being left on there. The GoPro really does not do well with these lights. Unfortunately, the GoPro is made for mobility, not for professional recording, I guess. it's not my type of professional recording. I have the ISO set as low as it'll go. While the brain is trying to kill me here. I have the ISO set as low as it go, and I have the frame rate set. It doubled the speed, which is what I use on the GH4 as well. But I mean, it really doesn't want to. It just really wants to blow out everything, which is weird because this is a camera made for outdoor shooting, but it's not made for professional recording, which I said before. It's meant to have on variable frame rate, in which case it would normally increase the frame rate dramatically to deal with the bright lights in here. But that doesn't help me at all when I need to import my video into Premiere. Premiere does not do variable frame rates. It doesn't know what to do. So that would just make things harder. He deserved better. I should have a better B-roll cam, but this is what I have to do for now. When I get my GH5, GH4 will do this job. And it'll be glorious 4K. It looks great. Wow. That's really gonna have to get hit with the sander. So anyway, I think you can get the point here. So that's Frankenstein's brain, and it's designed to fit in there like that. And if I turn the lights off, let's see if you can do it. See it up here. When I turn the lights off, it will glow in the dark. I don't know if I can do it. Yeah. Unfortunately, I'm sorry guys. It's just too much light in here to see it. But how cool is that? This one right here is the one that I've really been worried about, because this one was done with 100% infill. All this down here on the bottom is support material. Oh man. You would think that I was actually printing all this stuff on the bottom on purpose, as strong as it is. This is some strong stuff. I don't know. I honestly don't know a good way to pull this stuff off here. As I'm going to go ahead and suggest that when you're doing this, use some goggles. This is ridiculously strong stuff, and it wants to fly everywhere when it breaks off. If you have a technique for cleaning these things, for getting this support material off, let me know, please. There we go. This really needs like some needle nose pliers just so I can get something to stick down in there and twist, pull it off. Okay, guys, well, there's the jaw of it. Almost completely clean. The top part anyway. The jaw fits into this section right here, as you can see. It was broken on the other one, which is the reason I never printed the jaw for it. I don't think I'm gonna have that problem with this one. Anyway, as I get these cleaned up, I'll go ahead and take a photo or something and put that in the thumbnail or something, or at the end of the video. So anyway, hope you enjoyed this video, guys. If you have any questions, let me know. If you have any suggestions, please let me know. Anything you'd like to see, anything you'd like me to print, go ahead and tell me. And I guess that's it. My name is Elemento, and this is TechnoScope.
TechnoScope is a Twisted Curve production.